In this video we are going to explain the L'Hopital's rule. Here it tries to explain mathematically if we have indeterminate form 0 over 0, like here. If you apply the 3 here, 3 squared minus 9 over 3 minus 3, it's going to be, which is equal to 0 over 0. And from limit, we remember 0 over 0 was indeterminate form, and the solution method for this one, factorization. But here we can factorize the functions. We can factorize x squared minus 9 and we can simplify. But there are some kind of functions that we cannot factorize. So for this kind of functions, we are using L'Hopital rule. What is L'Hopital rule? Fx over gx, limit x tends to a. If it's equal to 0 over 0, if it is equal to 0 over 0, then get the derivative of numerator and then get the derivative of the denominator, and of course both should be exist, and then the derivative, the limit value, apply again to your function and find the limit value. If I solve this question 0 over 0 indeterminate form in limit topic, we should solve like this: limit x tends to 3 x squared minus 9 over x minus 3 is going to be equal to limit x tends to 3 x minus 3 times x plus 3 over x minus 3. It's going to be, when you simplify x minus 3 and x minus 3, then you can have limit x tends to 3 x plus 3 it's going to be, and then you will replace 3 by x, and 3 plus 3 is equal to x by 3, and in the result it's going to be 3 plus 3, then it's going to be equal to 6. Okay, here the limit value is equal to 6, and L'Hopital rule helps us to find this one easily, like this. This is the first way, and the limit way this is, and the second way is, now we are learning the second way, is the L'Hopital rule. Limit x tends to 3 x squared minus 9 over x minus 3 if it is indeterminate form 0 over 0. When I ask this question, I repeat this part again, and it's going to be equal to limit x tends to 3 derivative of x squared minus 9 over x minus 3 derivative. The derivative numerator, derivative of the denominator. Be careful about this one also. This is not the division's derivative. Okay, then limit x tends to 3. This is going to be equal to derivative of x squared is equal to 2x, derivative of 9 is equal to 0, derivative of x is equal to 1, 2x over 1, which is equal to limit x tends to 3 2x, which is equal to 2 times 3, and again it's going to be equal to 6. We can solve by using the indeterminate form, limit of indeterminate forms, or we can use the help of the L'Hopital rule. Both way is going to be. But here for the questions, we can use the solutions only for the questions 0 over 0 indeterminate form. Here when you apply, firstly I should check that one, I mean that one here. When you apply the value here, let me change the place of it. It's going to be equal to, it should be equal to 1 square, 1 cube actually, 1 cube plus 2 times 1 minus 3. I applied the value, and 1 minus 1. It's equal to 0 over 0. So this is the 0 over 0 indeterminate form. If it is 0 over 0 indeterminate form, now I may apply the derivative, L'Hopital rule here. X cubed plus 2x minus 3 over x minus 1 is going to be equal to limit x tends to 1 x cubed plus 2x minus 3 derivative over x minus 1 derivative it's going to be, and that's equal to limit x tends to 1 3x squared plus 2 over 1. It's going to be 1 3 times 1 squared plus 2, which is equal to 5. It's going to be Okay, we found for the first one. And the second one, I tried to explain this one. I said like this, it should be 0 over 0 indeterminate form. Now when I apply 4 minus 4 over 4 square minus 4, which is equal to 0 over 12, and this is not indeterminate form. So the answer of this question, we are not going to apply the derivative here. We cannot apply the direct derivative or L'Hopital rule here. That's why there is no indeterminate form. That's why we should get the limit value directly. So the 0 over 12 is going to be equal to 0. Okay, the next one. X cubed plus x plus 2x plus 1. X cubed, when you replace, we know that one, it's going to be equal to minus 1 cube minus 1 plus 2 over minus 1 plus 1. So first I try to get 0 over 0 indeterminate form. Minus 1 plus 2, this is 0, minus 1 plus 1, it's equal to 0. 0 over 0 indeterminate form I found. After this step, I should apply the L'Hopital rule. L'Hopital rule says limit x tends to minus 1, x cubed plus x plus 2 derivative over x plus 1 derivative it is equal to. And it's going to be equal to, here, limit x tends to minus 1, 3x squared plus 1 over 1 it's going to be, which is equal to 3 times 1 minus 1 squared plus 1. It's going to be, because over 1 it should be 3x squared plus 1, and the answer is going to be equal to 3 plus 1, which is equal to 4. Okay, now at the beginning I said like this, it's easy to apply for the polynomial functions the limit rule, which means factorization. But here we cannot factorize the term. If you apply this one here, limit x tends to 1, it's going to be equal to ln 1, which is equal to 0, and 1 squared minus 1, which is equal to 0 over 1 minus 1, that's equal to 0 over 0. And as you see here, if you remember the first question, I said there are two ways to solve this question. The first way is factorization, and the second way is L'Hopital rule. And we can solve the question by using the both way. But for this question, we don't have another chance. We have to use L'Hopital rule, and it's going to be equal to ln x derivative over x squared minus 1 derivative is going to be. And that's equal to, if you remember, the derivative of ln x is equal to 1 over x, and the derivative of x squared is equal to 2x. The answer is going to be equal to 1 over 2x squared. Pardon, these are all with limit. It should be written limit x tends to 1 over x over 2x it should be, and that's equal to limit x tends to 1 over 2x squared. And here, when you apply the term 1, we don't have any undefined problem or indeterminate form. That's why directly I'm applied, that's equal to 1 over 2 1 square, 2 times 1 squared it's going to be, and that's equal to 1 over 2 going to be. Okay, the next question. Here, this is another example that we cannot use the factorization method, so I have to get the derivative of this expression, and I'm going to get the derivative here like this. Limit x tends to minus 1 square root of 2x plus 3 minus 1 derivative over root of x plus 5 derivative minus 2 derivative, sorry. And as you see here, when you apply, actually I didn't check, but when I tried this number from the mind, I found the 0 over 0, that's why I continued directly. But in the exam we have to show this kind of thing, that's why let's show this one. It's going to be equal to 2 minus 1, 2 times minus 1, 3, minus 1 over minus 1 plus 5 minus 2, which is equal to root 1 minus 1 over root 4 minus 2, which is equal to 1 minus 1 over 2 minus 2, 0 over 0. It's going to be, this is the indeterminate form. Okay, now I can apply the L'Hopital rule. Derivative of this expression, it's going to be equal to limit x tends to minus 1, 2x plus 3 to the power of 1 over 2. Derivative, it's going to be, this part it's going to be equal to 0. That's why I'm not writing anymore. And here, this one, it's going to be equal to root of, not root of, x plus 5 to the power of, x plus 5 to the power of 1 over 2, derivative going to be again. And then it's going to be equal to, this is going to be equal to limit x tends to minus 1. Here 1 over 2 times 1 over 2 times 2x plus 3 to the power of 1 over 2 minus 1. It's going to be equal to 1 over 2 minus 1. It's going to be times 2x plus 3 derivative. It's going to be, you remember this one from the chain rule. And for this one, 1 over 2 x plus 5 to the power of minus 1 over 2, actually 1 over 1 minus 1 over 2, it's going to be, sorry, I made a mistake here, it should be 1 over 2 minus 1 times x plus 5 derivative. The chain rule was like this: fn x derivative is equal to f to the power of n times f to the power of n minus 1 x times f derivative x, it's going to be. And here 1 over 2 and 1 over 2 we may simplify, and these derivatives are going to be equal to the negative power, so it should be written like this. If the power is negative, it should be written to denominator, so 1 over 2x plus 3 to the power of 1 over 2 times derivative of 2x is equal to 2, derivative of 3 is equal to 0. It's not written. And here this one, it's going to be equal to 1 over, I forgot to write the limit again, limit x tends to minus 1, 1 over x plus 5 to the power of 1 over 2. I'm writing the power positive because I'm sending to denominator. 1 over 2 minus 1, it's going to be minus 1 over 2, and when we send the 1 over 2 to the denominator, it's minus 1 over 2 to the denominator, it's going to be plus 1 times 1. The derivative of x plus 5 is equal to 5 is equal to 1. Then it's going to be equal to here limit x tends to minus 1 over root of 2x plus 3 over root of 1 over, again I forgot times 2 here, 1 over root of x plus 5 times 1, and times 1 is not written here. Okay, the answer, it's going to be here. Now when you replace the minus 1 again, 1 over 2 times, or let me write here, 1 over 2 times in the root minus 1 plus 3 times 2 over 1 over root of minus 1 plus 5 times 1, it's going to be maybe, it's equal to 1 over 2 times minus 1, it's going to be equal to minus 2 plus 3 root of 1, it's going to be times 2 over 1 over root of 4, it's going to be, and 1 over 1 this is, then it's equal to 2. 1 over root 4 is going to be equal to 1 over 2. 2 over 1 over 2, 2 times 2 it's going to be, then the answer is going to be equal to 4.